Pump affinity laws, VFD speed control, and impeller trimming. Every centrifugal pump has a characteristic HQ curve at its rated speed. At zero flow, the pump reaches shutoff head. As flow increases, head drops, following a quadratic relationship. The best efficiency point, or BEP, is where the pump operates most efficiently, and the system curve shows the head required by the piping network at each flow rate. Where the two curves intersect, that is the operating point. The affinity laws are three simple relationships that govern how pump performance scales with speed. Flow scales linearly. If you reduce speed to 80%, flow drops to 80%. Head scales with the square. 80% speed gives 64% of original head, and power scales with the cube. 80% speed means only 51% of original power consumption. These laws apply to both speed changes with a VFD and impeller diameter changes. With a variable frequency drive, we can change the pump speed in real time. Watch the curve. As we reduce speed from 100 to 85%, the entire HQ curve shifts down and to the left. A new, smaller curve appears at 85%. The operating point slides along the system curve to a lower flow and head. Reducing further to 70%, the curve shrinks again. Each speed produces its own HQ curve. The key advantage of a VFD, it is fully adjustable. You can change speed at any time to match demand. Impeller trimming achieves a similar effect by reducing the impeller diameter. The math is the same. D2 over D1 replaces N2 over N1. As the impeller is trimmed from 100 to 92%, the curve shifts down. At 84%, it shifts further. The critical difference? Trimming is permanent. Once you cut the impeller, you cannot undo it. Also, at large trims beyond 15%, real-world performance deviates from the affinity law predictions. VFD gives you flexibility at higher cost. Trimming is cheaper but permanent. The system curve has two components. Static head is the elevation difference the pump must overcome, constant regardless of flow. Friction losses increase with the square of flow rate. Together they form the parabolic system curve. The operating point sits where pump and system curves intersect. This tells us the actual flow and head the pump delivers. Here's the dramatic payoff. Power scales with the cube of speed. At 100% speed, full power. Reduced to 85% and power drops to 61%. That is a 39% energy saving from just a 15% speed reduction. At 70% speed, power drops to only 34%. A 30% speed reduction saves 66% of energy. The cube law makes VFDs one of the most cost-effective energy-saving measures in pumping systems. All of this analysis is built into Flow Analyzer. Pump curves, system curves, and operating point calculations all in one platform. Flow Analyzer Suite, hydraulic engineering tools. Subscribe for more. Thanks for watching.